This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
So, welcome everyone. I hope you're having a good time. Are you? Yes. Very good. So, first question. Who uses Power BI? So the rest will be using, okay, in 2 days' time or something like that. From those who use Power BI, who's got performance problems? I hope all of you, because this is session for you who want to improve whatever you do with Power BI. And I will be going through maybe like three cases which are kind of a less known, they are less frequently presented. They are people usually do not go that way. But what I want to do, I want to show you different ways of those different ways of optimizing your models. So you're not going to be lost in your journey, in your analytics journey. So first of all, let me introduce myself. My name is Hubert Kobierzewski, and I work for Cogit. This is a small consultancy company. We do mostly budgeting, planning, and business intelligence. The other activities are like teaching on here on Technical University in Warsaw and on Kobierzewski University. The other things that I'm kind of active in Data Community Poland. Who knows me from Data Community Poland? This is, very well, yes. These are professionals who gather from time to time. I do also meetups once a month, talking about different technologies from Microsoft Suite. We also organize once a year, we organize big conference called SQL Day. Do you know Guy in the Cube? Patrick Leblanc and Adam Saxton, they are going to be here in Poland in May 2025. So if you watch out for our, social media, then you'll see when the registration will start and so on. So let's talk about performance problems and solving them. First of all, no matter how big corporation you work in and how tight security team keeps your systems, DAX Studio is a must-have. Even if some DAX querying has been introduced recently in Power BI Desktop, this is maybe the only functionality that you have which was present in DAX Studio before. So DAX Studio before is a pro tool for those who are trying to dig a bit deeper in performance of their systems. So what cases are we going to cover? First one is one big table. It's a common case. People who usually are kind of like data analysts, they're used to working with Excel or Tableau. This is their case, one big table. Very important thing in writing DAX code in your when you enhance your Power BI model is what methods to use when you're filtering your data. So I will present you kind of two different approaches and how much they differ in terms of how fast your DAX query can be. And we know those who write a lot of measures, they sometimes go into switch function or if function. and they may experience issues, and I will show you how to solve it by changing the shape of your model and abandoning heavy switches. Maybe not completely, but heavy switches will be off. So that's all for my slides. Everything will be based on demos. Okay, so first of all, Tax Studio, it's a tool that that we use. I'm going to show you that in a minute, but where do we start? Where is our environment? What we are going to cover? First of all, I got my workspace. As you can see, this is a premium workspace. I will be looking at that because it allows me to plug in with Tax Studio and then check the performance of my queries. The other thing is that I want to show you my models, and I got two of them. First one is a regular star schema. So if you don't know what star schema is, you need to read Kimball books, and this is absolute Bible in terms of shaping your model. From ground up, so facts, dimensions, hierarchies, and so on, and which information where to put it. So I'll show you that in a minute, and maybe not in a minute, in a few seconds, how a star schema looks like. Huh? Okay. Unfortunately, it's kind of is it blinking for you also? So maybe we should use other method. If this will be persisting, then I'll switch to other type of connection. But first of all, star schema is a situation where you see. Look, this is your fact table, and there are some dimensions table surrounding maybe currency exchanges is a different thing. Is it too often blinking? Not yet. Okay. Tell me when it starts to be annoying. Okay. So first of all, this is fact table. That sales is trimmed at the moment because normally it contains like 200 million records. I just cut it to years. It should not be too big now. Don't break it. At the moment, my sales is, oh no, only 7, no, this is store. Oh yeah, sales is here. We got only 40 million records, yeah? So this is not too bad. Okay, so what is the difference between star schema and one big table? One big table is usually when we take that fact table. You've seen those 40 million records, and we put all the information about products, about stores, about the dates, any other dimension. So we've seen like a lot of, maybe not a lot of, but we've seen few tables around, and people, when they use joins, they connect everything together into one big table. And some people say, okay, this is fine because I got everything in one place. And is there a performance drawback in this case? So let me show you what is the size of those two files, two Power BI files, once the same data is loaded up. The only difference is in one of them I got star schema, and the other one I got one big table. In theory, we should have exactly the same amount of information. The only difference is that I have no additional key columns coming from dimension tables like product key, like customer key, etc. So But before I show you the size, look at the situation where we have one big table. And this is that one big table. It's called sales. And if I go there, here, this is sales. You see the same amount of records. This is 14 million, but it's a bit wider. All those dimensions which I had before, they are all in there. And what is the how you can detect what could be the size of or detect size of the problem? If you can see here, I'm not sure if you can see it here. The one with star schema, well, it's a 200 megabytes. The one with one big table, same information, same compression methods, it's almost more than 2 times bigger. So Power BI does not like those big tables. It is just compressing not too well, and you just then when your queries hit that model, then they will be slower because materialization of data will be much slower in these cases. What are further drawbacks of this situation? So I got another problem in this case because look, these are two models published. This is F122 fabric capacity, and if I look at the refresh history, same amount of data, maybe a bit bigger than those on my laptop, but I don't know. Okay, sorry. Maybe like this will be better. No. Let me show you what was the processing time in here. Maybe it's not too clearly visible, but it's this recent processing started like 7:15, finished 7:50, so it was around 35 minutes. That was processing time. In case of one big table, what do you think? What the processing time could be if the size is two times bigger? It's not finished. I started at 8:30. It's not finished yet. It's still in progress. So, of course, your solution could be to create partitions in here, and then process them one by one. But I wanted to do that for comparison reasons. Do not do too wide fact tables which contain this information, which is dimensional information in your model. That's why you may see, first of all, your users will be waiting for the data a bit longer, and the other thing is that you will take more capacity space in here. You're going to pay more. So constructing your model in the shape of star schema will save your employer money. Any questions about this big table thing? You may save your questions for later if you want. Okay, another case. We were talking about filtering. So I'll show you a bit of a code, but first of all, DAX Studio. DAX Studio is a tool that we use for querying data. We are looking at size of our models. We look where the compression went well or not. But first of all, I wanted to connect to to my model. Who was working with analysis services before, like multidimensional one? Okay, thank you. So actually, it's like the same. It's a similar situation. So it's like we have tools we can connect to server. Connection string we take it from Power BI. I'll show you where it is, and then okay, sign in. Of course, super security. All right, I want to stay signed in, and it will never stay. Don't worry. So where is the connection string? Once we go to our capacity, then if we go to settings, in settings we got something like server settings, and those server settings. This is a connection string to my DAX Studio. And if I hit connect, I can paste it. Of course, this is a different tool. I need to log in again. This time I need to type it in. And of course, confirm 100 times. Un momento. Okay, that's it. I'm connected. If you were working with SQL Server, it is a little bit like a management studio, but just allowing you won't be able to do any administration, but querying and constructing queries and checking properties of your model. This is it. Sometimes it takes a little bit longer to connect, but maybe I can use also my local model, because what you can do is like you can work also with your local files. If you select here we got a chance error. Let's connect with our local model. It will be a bit better working with it. So what is the most important word when you query DAX? This is a question for those who work with DAX. What is the first word usually when you use? What is the key word that you use when you query DAX? Evaluate. Very good. There's no query without evaluate. So my case is I'm going to check my my model, the performance of my model with some measures. So I'm going to write a new or test a new measure, or test a code for new measure. This is going to be a cost. So if I want to test something, I may define a local measure, the measure that does not have to be defined in my model, but the one that will be just declared locally. So if I come here, first attempt in my case will be to create a measure. This is a testing of cost. So I'm taking the quantity column, multiplying by unit cost, but I want to do it only for those lines where the total cost is higher than $150 US. And This measure uses some X, so it will go through sales. You have seen the sales, 14 million records. First of all, filtering of rows which have too low value. And let's check it. Let's check the performance. I'm going to press this little button, clear on run, because that one will. It is guaranteeing that every time I run query, the cache is cleared. So let's test it. There are some results here, but before you test it, the most important button is here. It's called server timings. And once you enable it, the DAX Studio will start a trace to the server, to our model. And if we run our query, what you're going to see is this little tab called server timings. And if I go here, I can see how long did that take to execute that query. So I can see now currently that query or that measure takes nearly 400 milliseconds. Okay, it might be a good time, but remember, if you put it into matrix, if you put measure into matrix, and that matrix has 100 cells, so this matrix will retrieve that data. Will retrieve that data in like 4 seconds. That might be sometimes too long for end user. Is there a better way or a different way to construct this query? We may try to use the filter maybe against this table, not necessarily in the situation where you already go through all of those records from sales table. Let's have a look at the other case. So in here, I am modifying this measure a little bit. So here you've seen that was a whole sales table, and now it's a sales table, but this is filtered. So I'm going to put a filter on a table that I'm iterating, and then the result of a filter function, it will be my expression. Let's change it, run it, and see if it is any better. And as you can see, this is around 3 times better in this situation. So it is because there was like a smaller number of records which we were going through, and we didn't see any improvements in terms of number of records that they were going through in here, but the change of a shift in filtering improved our measure. So, and what you can do also, it's like every time when you run the query, because if I go back to my original one, if I run it, and if I click this one, what you can do, you can also have a look on each individual query. And if you see callbacks, then it means that you are in trouble. Because callbacks are when formula engine, this guy, goes to storage engine back and forth. And if it happens a lot, then this is usually because it's like storage engine is usually very effective. If we see something like this, that the more of a performance goes through storage engine, this usually means that the queries are fast. But in this situation, it's like it retrieves data from storage engine, goes to formula engine, and formula engine iterates or runs queries to storage engine callbacks, runs callbacks, and then we have bigger performance problems because storage engine is multi-threaded, so it can run multiple, it can process that data in parallel. This one, it's a single-threaded. But those queries from Formula Engine to storage engine are going to be, unfortunately, single-threaded. Maybe if I do something like this, maybe if I disconnect my additional... okay. Sorry, I want to try this way to see if this is going to be a bit better for you. Where is my mouse? Okay, let's examine another case where we change it a little bit. I'm going to test if maybe calculate is going to be a better choice, because we use filtering a lot in calculations, because this is this is the reason why we have calculate as a function. So this is going to be an expression like a sum, but I am going to filter sales before it gets to that measure. Alrighty, so this is 150B, and run it. So the result is that we kind of go back to this square one, because if you remember, we had that performance before, like it was around 400 milliseconds. This time we got two queries to the Vertipack engine. First one calculates that filter. The second one calculates this expression, and you can see that we have much like a higher number of records that we process, because before we had maybe 2 or 3 but wider records. Here we got nearly 100. But the performance is similar to the first case. No callbacks this time, so you may think it may look better, but the problem is that when you filter the wholesale table, it will materialize wholesale, all columns that are in there. And what we usually want to do, we want to consume as less memory as possible. So what to do to achieve that? We need to focus only on those columns which we use for filtering. So if I go here and paste my code, look, what I'm doing here, I'm changing this table, the sales table, into an expression which comes back with it's a table expression. It's a function which comes back with a table expression, but there are going to be only two columns in there. Only combination of all values of a quantity and unit cost. So let's check if the performance in this case is going to be any better. Hit run. Drums. No, not necessarily. But let's test the gain. And now it's okay. If you want to do some sort of a better testing, it's always good to do that multiple times. How to automate it? DAX Studio will help. If you go to advanced, there is something like a run benchmark in here. If you press it, then you get a choice, like how many executions you want to make with the cold cache. Cold cache means now no data is materialized. It's clear cache, nothing. And how many of them should be with a warm cache. Warm cache is a situation when you have already executed the query and some of this data is already present in the memory of the engine. I don't want to do anything with the warm cache. Everything what I need, all what I need is just those 5. This query executed 5 times with cold cache. And this is 5th time. I'm going to get some statistics in a second. Okay, so the average is 600 and the minimum value was 111, maximum. It's kind of a wide, maybe because my machine doesn't necessarily work as a stable one. We can test something else. Let's make a test with A because that was the best one. And let's have a look if there are if this is any difference in performance. The 5th time, the last time, and ta-da! It's also in the same. It's average is about 700. The smallest one is this in the same, almost the same situation. So it's around 100 milliseconds. Let's check. Let's make a benchmark with those ones which were not performing too well. This is going to be a bit bigger. Sorry for that screen blinking. Didn't expect that. It's a little bit longer because that measure is less performant. Here we go. Average is 2000. Yeah. So you see that code is less performant. So DAX Studio is absolutely your friend when you test your DAX your measure written in DAX. Especially, you should pay attention to those queries, the number of queries, number of records that they are going through, so number of rows when you process, the balance between formula engine and storage engine. We like when more of the code runs in storage engine, but long execution times might be caused by callbacks. So you need also to check if there are any callbacks, and then if they are, try to mitigate them. Alrighty, so that's it for filtering. Of course, if you are talking about filtering, you need to know that, for instance, using of treat as function is better than anything else, and so on and so on. I'm not going to deliberate on filtering more. Maybe go to some videos on YouTube or books. You're going to find more information on that. So, if statements, if switches, and so on. This also usually is a problem. I am going to show you a few examples of reports that I have created with my colleagues before, and what kind of a journey we had from switches to a little bit different model. But before that, maybe it will be better to close this big model. the one with one big table. The other one, I don't need it anymore, but it's not that big. Okay, what I'm going to show you the method that you can already use for performance testing in Power BI desktop in a situation when not necessarily you have access to DAX Studio. Of course, having DAX Studio will be much, much better, but in Power BI desktop, you also have like a performance analyzer. Second, okay, so this is my report. This is my P&L statement report, and that's kind of an older version of it. And on the second tab, I got a report which will be able to, where we will be able to show the results of that P&L statement. But before I run it, I can go to view, and then you see something like a performance analyzer there. If I see it there, it should also be visible on the right-hand side. Sorry, I have turned off my, oh yeah, performance analyzer. How do you test with performance analyzer? First of all, you need to freshly open your report on a page where there is no data code. So it means that there is no query executed at the moment. So also, like, no data has been materialized. And then have your report prepared on a page with the data that you want to test. And before testing it, start recording. If I go to start recording, Power BI begins to listen. And if I go to my report, I just press just grid. Power BI desktop will turn to that page, and then you see there is a matrix which is like trying to show me the result. And at that time, okay, I was trying to build like the best P&L statement possible, and it looks legitimate, it looks good, but the execution times that I see in here, if I go there, this is like, this is like 9 seconds for DAX query in here, which is kind of long, because every time you click, every time when I select anything in here, it's going to be minimum 5 seconds on this machine. So not so performant for such a small matrix. So after a few years, especially when I've seen Bob Duffy's session about building P&L statements, or actually building financial reports, I realized that he used a different approach. He didn't use switches a lot as I was doing, because if you have a look, if you get a look at the one of the measures, it's called subtotal P&L. I'll try to find it in here. It should be under actual. Yeah, subtotal P&L. Go here. Look, it's a one big switch. My plan was, okay, if I have a P&L statement, some of those lines, they got a data beneath. Yeah? Sales, it comes from accounts that are for sales. Total cost of sales, this is for cost of sales. Like operational cost, yeah, salaries and rents and everything like that. But there are also lines with no data, like gross margin, for instance. It's just a calculation, not a line with the data. And that's why what I usually was doing, I was building a separate measure for each one of those lines, and then I was using switch. And that was a pain in terms of performance. So after seeing Bob Duffy's session, I built another one, another version of PNL. This one contains very similar data. It's based on a similar structure. It's just that the shape of a model is different, and of course measures are different. Okay, I'll start recording in here, so we will see how this is different in terms of performance. Visualization is also a little bit different. You can see it was running 2 times, but it's not that important because I have a matrix here, and the same data, which you see here, maybe little bit different figures because they are from different period. But the DAX query, it's not 9 seconds. It's a little bit over 1.2 seconds. So, and question how that was achieved. So, the difference is in modeling approach. Let me show you how was that looking in the original one. In the original one, all those lines which you've seen on the left-hand side, like sales, OPEX, and so on, they were here in PNL header, and then on the second level was here in account group, but they could be like a one table. Straight from this table, I got a relation with the dictionary of accounts, and later account, budget, and then on the bottom there is a general ledger. So it was like a headers, those lines which you've seen, accounts, and then data comes from general ledger. And for those lines, like if I look at let me show you the PNL table. These are accounts, but PNL headers are here. These are those just main lines. Yeah, and then account group was just an extension of each one of them. So how the second approach was different? The second approach didn't use switch that lot, but what happened was that I have consolidated that information about headers and account groups in one table. It was called financial report, but it doesn't matter, because I could do it also before. But what is the difference here? It's something called, it's a many-to-many, as you can see. Here is a many sign, this is many sign, so it's a many-to-many table where in external system, I don't know if I can do it in Power Query, but for me, SQL code in store procedure was actually something that I could use easier, but I created many-to-many table where for each line on the report, so if I go there, let's say I have a gross margin of a first level. So each one of those lines, it has a relation with the data, especially through that many-to-many table. Because if this is sales, okay, only accounts related with sales. If this is cost of sales, only accounts related with cost of goods sold. But with gross margin, in theory, this is a difference between those two numbers. But in the model, it's actually, I got in here on this level, I got all the lines from sales, I got all the lines from cost of sales. I just use different sign when I add everything together, and this is just a simple sum. And by having a simple sum, I could use ifs and switches in a less frequent manner. And that's why this way is more performant than using a switch with a lot of cases. Any questions? Because that's all.
Showed before. So
DAX queries?
yes, evaluation queries. So this question is about, have you tried to put the basic query into ChatGPT and then ask it for create like
Better version of
yes.
it.
Does it work in DAX?
Mark Russo was testing ChatGPT in terms of how good ChatGPT is in terms of improving our queries. Unfortunately, the results of he's got a video on the SQL BI channel, YouTube channel, and the results were that he was not happy with that. Once because they were not giving good results in terms of optimization of a code. The other thing is that sometimes you need to know what is your layout of your model. And sometimes using a different approach depends on your data, on your shape of your model. The other problem was that ChatGPT was giving you hints about functions that do not exist in DAX. But what you can do, if you have the possibility, you can build your own LLM model, but you have to feed it only with articles about DAX. And this will be definitely much, much better than a general ChatGPT model.
So small model for DAX.
Yes.
Thank you.
Okay, are there any more questions? Yeah.
It's maybe not rather the question, but 2 points to the previous topic, because I tested ChatGPT for the optimization for the Transact SQL. So it's a lot of sources online or even the Microsoft documentation that probably was used for the training for that model, and it doesn't work properly. It's good for some basic things or some maybe even syntax errors, but any optimization doesn't work properly. And also I cannot find any solution to fix some maybe more complex issues related to the performance. So I think that ChatGPT is not the best tool now for that kind of work.
Maybe we are not there yet. Okay, that is the answer for that question. Anything else that you want to know about optimization? Maybe in general about Power BI or Fabric.
A book at the beginning of your presentation.
The book? Kimball, yes. Data Warehouse Toolkit. That's, I think there are 3 editions. They are not different too much from one from another, but they are kind of an improvement of Kimball method. And as I said, it's a Bible for data analysts, for those who want to build models that perform. It's a kind of that book, it's not just a theory, because majority of the books, it's like he takes an industry and then he explains what types of processes you get in an industry, and then he describes how he would build a model for that industry. And we got minimum like 10 different industries there, so you can just grab from there and build your own model based on those which you find in the book.
Okay, anyone has a question for Hubert? If not, so please welcome Paweł on the stage. Big applause for Hubert, of course.
Thank you.
Thank you.